In section 3B here, we're going to look at what's called factoring completely. That means you need to take all the factoring things you know and factor as far as you can. Now, kind of your first step in every factoring problem is to factor out a greatest common factor from each of the terms if there is one. Okay? Then see if you can factor what's left after you've done that. Whether it's a trinomial factoring, or whether it's a difference of two squares, or if anything else can be factored further. But first step is always factor greatest common factor, and then finish factoring what's left inside parentheses. Okay? Now, we're going to do number 9 here. And if you look at this, I've got two terms. Anytime you have a binomial and they're asking you to factor, check to see if it's a difference of two squares. And notice, I can actually, if I have b to the fourth as this first term, and I have 16 as my second term, and it is a subtraction, so it's a difference, I can square b squared to get that first term. So b squared squared would be b to the fourth. It's a difference, and I can square 4 to get the 16. So this is a difference of two squares. So if you think back to what we did in 3a with a difference of two squares, a difference of two squares factors into two binomials. Now, I said factor greatest common factor. I guess I didn't say this earlier, but on number 9, there's nothing that you can factor out. Like I can't take a 2 out. I can't factor that out first. Okay, some of the problems in section 3b here, you're going to be able to take out a 2 or take out a 6 or take out a 9 or whatever. Always do that first and then see if you can factor what's left. In this particular problem, we could not. But so then this is going to be b squared. If you think back to difference of two squares that we just did in the earlier section, or in 3a, and then one's going to be a plus 4 and one's going to be a minus 4. Now, up in that top section in 3a, a lot of times you were done just factoring a difference of two squares. When they say factor completely, you have to check everything. Well, is this factorable or is this factorable? Whether you factor out a greatest common factor or whatever you did as your first step. Now, if you look at the first binomial there, it's b squared plus 4. That's actually a sum of two squares, and a sum of two squares is not factorable. A difference of two squares is, but if you look at this second thing, we have b squared minus 4. This is a difference of two squares. I can square b to get the first thing, and I can square 2 to get the 4. So this right here is a difference of two squares, which can be factored further. So I keep going here. I just carry down my sum of two squares, which is b squared plus 4. Can't do anything with that. But now this right here, this binomial is a difference of two squares. It factors into two binomials just like you did earlier. Okay, we squared b to get b squared, so that goes in the first spot in each. We squared 2 to get the 4, and then one's a plus and one's a minus. So the whole factored answer, again, you had to carry down your b squared plus 4, is this right here, and that's as far as you can go. Okay, so always check in this section, can I take out a common factor first? Can I take out a number, a 2, a 4, whatever? See if you can factor what's left. In this case, we factored a difference of two squares, and then we ended up with one of those being another difference of two squares, which could be factored further. Factoring completely means factoring as far as you can till you can't factor anymore.